Go really quick once we get to the end. So this one, the table above shows the height in inches and the arm span in inches for 10 randomly selected high school students. Before I even keep reading, is this a 2 sample or 1 sample?
1 sample.
1 sample, because I take 10 students and just record 2 things on it. So it is definitely not a 2 sample, so it is not A and B. Which of the following significance tests should be used to determine whether a linear relationship exists between height and arm span? That second sentence, what is the one most important word? Or I guess 2 words. Basically 1 word. It is testing this. What is my only option here that is actually testing a linear relationship? Slope. Chi-square goodness of fit is going to be 1 variable in different categories. We've got 2 variables up here. We've got height and we've got arm span. So it's definitely not going to be chi-squared. Chi-square tested independence is going to be 2 variables, but it's going to be in a 2-way table where it's like this direction is variable 1 and this direction is variable 2, which is not what this problem is. So some people could read this one and go straight to, okay, linear relationship and slope. But if not, then you can go through and think of each one to cancel them out to get to the same answer. So 25 is E. Number 20. Automobile brake pads are either metallic or non-metallic. An experiment is to be conducted to determine whether the stopping distance is the same for both types of brake pads. So just in that second sentence, I'm doing an experiment. I've got an explanatory variable and a response variable. What is my explanatory variable? Okay, let's go backwards. What is my response variable? What is the thing that I'm measuring? What is the thing that I'm measuring to see if it impacts that response variable? It's the brake pad surfaces. And it's the fact that it's the material of the brake pads, but it is brake pads. You don't need to draw this, but so that would mean I've got my individuals, my different cars, tires, depends on how we did this one. So with that, we would, I don't want to get there yet. I will in a second. And all of these are asking about blocking. Do we want to block by our brake pads? No. Do I want to block by what I'm measuring? No. I don't want to categorize you by what I think your answer is going to be. So it comes down to this. So my next sentence, in previous studies, it was determined that car size is associated, but car type is not associated. So this one does impact your stopping distance. This one does not. Which one do we have to worry about? The one that is going to impact what we're measuring or the one that's not? The one that is, so we want to block for that. So you block for an external variable that may impact your response variable. And there's a word for it. If we don't block for it, then we would consider that to be a potential source of what? The C word, what? Confounding. The possible confounding variable, that's the one that we blocked for. This part is definitely outside of the problem. But if I wanted to think about this one as a randomized design, I would start out with cars and however many there were. Then I would randomly assign. And then I would randomly assign them into groups and give this group metallic and give this one non-metallic. And then compare our results. If we instead block first, then we would take our cars and then block. Actually, this is 3 different types. So this would be small, medium, and large. And then we would basically do one of these based from each one of those branches. So we would pretty much do the experiment here, then here, then here, and then compare them at the end. So blocking is just, I split them before I randomly assign because I think something's going to impact it. All right, number 8. A high school physics teacher was conducting an experiment with class on the length of time it would take a marble to roll down a sloped chute. The class ran repeated trials in order to determine the relationship in length between the length in centimeters of the sloped chute. So this is one of our variables. And then this is our other one. The linear relationship was observed and the correlation coefficient was 0.964. Aside from the problem itself, but a correlation is what symbol or letter? That's my what? R. Tell me 2 things that means about this linear relationship. To be 0.964, it's what?
Very close to like the relationship.
So it's a strong relationship and it is specifically positive. Now that's not helping you answer the question, but I want to talk through episode 1. After discussing the results, the teacher instructed the students to convert all of the length measurements to meters, but to leave the time in seconds. It's easier for me to draw this one with, I don't know what the conversion measurement is for centimeters and meter. It's like 30. Nope, I was way off. It's like 90 something, maybe. I don't know. I don't remember the conversion measurement. So let's say that I've got this graph. And these are my length in inches. This is my time in seconds. And all of a sudden my teacher says, I don't want to do these lengths in inches anymore. I want to switch them to be feet. What changed about my graph? Basically what? Basically nothing. So even though I multiplied all these by something, all R measures is how compact those are together. And when I change these from inches to feet, nothing changes. So multiplying one by something or converting it does not change anything. And there's only one that says does not affect. R does not care about units. R also does not care which one is X and which one is Y. So even if I switched them, like I said, all R cares about is how compact I can put them together like that. So even if I rotate everything, basically R can't read. R wants to look at where your dots are, and it can't read numbers, and it can't read words. If you switch the axis, it doesn't matter. If you switch multiply them and convert different numbers, that doesn't matter either. Just while I'm thinking about it because of time-wise, and I know people are like in and out, tomorrow starts your test. This is the second one of these. I will not take this piece of paper tomorrow. I will not take it because we need 45 minutes and 45 minutes, just like we did before, which means as soon as y'all come in, well, this class will, y'all have a little bit extra time, but like my third period, they have like 53 minutes in the whole class. And so as soon as they get in there, no, they have 48 minutes with me. So like as soon as they walk in, we start. So I'm not taking any of their stuff tomorrow, which means I won't require you to turn anything tomorrow because I won't make y'all turn in stuff that they don't. But I will take homework and that afterwards if you still have it with you.
Are you taking back what they have?
Like you're turning it in with the corrections that we've been making or the notes that we've been taking for the last week. It's like most people have it with their test, but if you just hand me the paper and not the test thing, I don't care about that. Most people just have it stapled together. All right, number 33. An independent research firm conducted a study of 100 randomly selected children who are participating in a program advertised to improve mathematical skills. Looking ahead at my answer choices here, if I want to test if it improved, is that one-sided or two-sided? What would my alternative be if I did this? Greater than. So that's one-sided or one-tailed. The results show that no statistically significant improvement. Well, if it's not statistically significant, that means my p-value is what? So it is, right now my p-value is greater than 0.05, or it's not less than 0.05. The program sponsors complained that the study had insufficient statistical power. Assuming the program is effective, which means we made an error, which of the following would be an appropriate method for increasing power? So let's just think about the things we wrote up here. How can I make this better to reject it? This one said, B says use a one-sided instead of a two-sided. What did we use? So that's not even an option because we started with the one-sided. If I make it two-sided instead, two-tailed, what's going to happen to my p-value? So like this was my p-value, now what's going to happen to my p-value? Is that going to help me be less than alpha? If I use a smaller alpha, is that going to help me be less than alpha? And now this is not how most of you are going to think through this one. I'm talking in a lot of detail through these. Basically, most of you are going to look at this problem and go, I don't have a clue. If you want to make a test better, what should you always do? That's pretty much always the case. If you want to improve something or make it better, interview more people. It's going to make your standard deviation smaller. It's going to make your results more reliable. And it is actually going to increase power. This problem does not really ask about this except a little bit in part C. But just while this problem asks about it, Hopefully y'all know what I'm talking about when I draw this. Which error is this one? Type 1. Do you remember what the probability of type 1 is? Something up here. What's my symbol? This is my first error. What's my first Greek alphabet? First letter of the Greek alphabet.
Oh,
So alpha is probability of type 1. This path is type 2. What's probability of type 2? Not alpha, but. And then which path is power? This first one or the one on the right? So I know the problem doesn't need you to go through this, but I'm just addressing this while we can. Do these change directly or indirectly? So if I want power to go up, do I need beta to go up or beta to go down? Down, because I either go here or here. So these work indirectly. Your errors, if I want one of my errors to go up, I would have to be willing to sacrifice my other error to go down. Those also work indirectly. And using both of those, so alpha and beta are indirectly, and beta and power are indirectly, then what are alpha and power? Directly or indirectly? If I want power to go up, beta's got to do what? Go down. If I want beta to go down, alpha's got to do what? Go up. So these work the same way. So if I want to increase my power, I'm definitely not going to decrease my alpha. So you didn't really need what I just drew to do this problem, other than maybe it helps you see. But I think it's like one of the only times it comes up in this multiple choice, so I wanted to go over it. This one was a little concerning. If somebody got this one wrong, I'm hoping they just didn't read it. Lynn is flying a plane from New York to Los Angeles and will take the airtight airline flight that leaves at 8 a.m. The website she used to make a reservation said that there's a probability of 0.7 that her flight will arrive in Los Angeles on time. Of the following, which is the most reasonable explanation for how that probability could have been estimated? Using an extended weather forecast on the date of her flight, which showed a 30% chance of bad weather. Maybe that's not terrible right now, but just if there's a 30% chance of bad weather, does that mean that it'll be delayed? And is that the only thing that can delay it? So maybe at first you don't mark that one out, but you just kind of keep going. Making an assumption about how airplanes work and factoring in all those assumptions into an equation to arrive at the probability. Again, yeah, okay, maybe. From the fact that of all airline flights arriving in California, 70% will arrive on time. Is that what we're talking about? It is specific, and 22% of people chose C. I think they just quit reading. So we're getting there, but we're just not there yet. From the fact that of all airline flights in the United States, well, now we're getting worse. We're getting more generic. On all previous days from this particular flight had been scheduled. So I'm being specific to this particular flight. Of particular flights that are just like this, 70% of those arrived on time. E is your best bet. E is your answer. I'm not as concerned with people missing A and B. I'm concerned with the 22% of people that chose C because they quit reading. Number 15. In a study of the, I want to get to where I wrote on this one. In a study of the weights of college athletes, player weights for a random sample of baseball players and a random sample of hockey players were compared. We are testing this. So we are testing that, put that in words. What is this testing? That the baseball players' weights are less than hockey players. This says mean weight of players significantly. One of these says different. Are we testing different?
No.
No. This one's talking about baseball players being higher. We're not testing that either. So at least the other three are testing baseball players being lower. And we get a p-value of 0.0076. So does that mean there is or is not significant evidence? Is that a high or low p-value? Low. So that means there is or is not. So is not. Answer is D. Oh, wait. Oh, no. I'm looking at this one wrong. Where is our alpha's over here? I'm looking at this as extra 0. Let me write this out. Our alpha in all of these, okay, these change. So if our alpha is 0.05, our p-value 0.076 is less or is not less? So for my ones that say 0.05, would it be is or is not? Is not. And if it were a p-value compared to an alpha of 0.10, it is less than, so it would be is. So here 0.10 should be is, 0.10 should be is. So our answer is A. Sorry, I was looking at that as an extra 0 there. All right, number 37. I wrote a lot when I started reading through this one the first time. So Dan, a trainer at the popular gym, was interested in comparing levels of physical fitness of students attending a nearby community college and those attending a four-year college in town. He selected a random sample of 320 students from the community college. So if I'm reading this, I'm just going to say subscript C is community college. This is my mu C, my sigma C. And then we also dealt with one of the four-year college. So this is my N of 4. This is my mu of 4. And this is my sigma of 4. And it gave us a test statistic value. And it also said two-sided. Now, because the two sample means only differed by 3, then they are not significantly different. Is that the only thing I look at to see if they're significantly different? No. I need to consider all aspects. That's not enough context, so this one is no. Because the second group had a larger standard deviation. Does standard deviation directly mean significance or not significance? No. So I get down to here, and now I'm thinking I need to go do math to figure out what my p-value actually is, because I need to either know that it's less than or it's not less than. And you could do that, but look at this connection here. If the p-value is less, then here it's saying they are significant. And here it's saying the p-value is greater, so they are. Which one would mean they are significant? The p-value is less or the p-value is greater? So this problem, you actually don't ever need to do any math to know that that's the correct answer. I could have gone and done a t with 3.25 or 3.27. What would you have used as your degrees of freedom if you wanted to do it that way? So if you wanted to attempt to find a p-value, and it tells us we have a test statistic of 3.27, what's our best bet of what to use as degrees of freedom? 319. The smaller one minus 1 will do the same. And if you typed in your calculator TCDF with 3.27 and 319, you get a really small number. Even if we multiply that really small number by 2, it's still less than alpha. So you could have gone and done it that way as well. Last 10. All right, 31. This one, I think people got confused because they made an association that they should not have. A candy company claims that 10% of its candies are blue. So we're considering blue to be success. And this is the probability of that success. A random sample of 200, that's our N. And 16 are found to be blue. That's our X, because we could use X over N to find P hat. Which I could write P hat would be 16 over 200. Which of the following tests would be most appropriate for establishing whether the candy company needs to change its claim? Am I doing matched pairs? No. Is it just one sample or two samples? It's one sample. So it comes down to these two. This one means we are testing every color. This one, we are just testing blue or not blue. And which one is this problem talking about? And I think some people went, oh, we did chi-squared with candy, so it's probably that answer. And that is not the case. All right, 38. In which of the following situations would it be most difficult to use a census? Again, honestly, 100% of people should get this problem correct unless you just didn't keep reading. What does it mean to be a census? What's the important part about a census? So I would talk about every single one in the entire population. To determine what proportion of licensed bicycles on a university campus have lights. What's the one part of that one that makes it not so hard?
License.
Or at least more reasonable? Now, could it take a while, or would it be something that maybe it would be a lot of work? Yes, but it could be done. So maybe I don't know if it's yes or no yet. Determine what proportion of students in a high school support wearing uniforms. How can I do that one?
Survey.
Survey. Again, maybe time consuming, but could it be done? Yeah. C, what proportion of registered students enrolled in a college are employed more than 20 hours a week? The one thing about this that I think people could possibly get confused with is thinking, well, what if I am one week and I'm not the other, I guess? But if they're registered students, it could possibly still be done, but maybe it wouldn't. So like right now, C is definitely better than A and B. To determine what proportion of single family dwellings in a small town have 2-car garages, could that be done? Yes, again, maybe efficiency, you actually have to ride around and do it, but now, does that seem like it's easy to acquire? I don't have like a list where they all signed in when they got there. Everything else I essentially do. So if you didn't keep reading, you might have picked C, but if you kept reading, surely you would have picked D. All right, 17. Honestly, I'm kind of impressed that this one went as well, because this one always trips up people for some reason. All right, so we've got 5 different things here: mean, median, standard deviation, first quartile, and third quartile. What goes with me? Which of these 5 things is most directly related with me? Like if I draw them on a graph, which one would I draw with me? These 2 I usually draw together, and then what goes with median? Those 3. So let's start with the median one, and let's do a box plot-ish. It tells us that there are 200. So if I have a box plot, I don't know what my number line is, and it doesn't have to be drawn to scale, but I can kind of think ahead here a little bit. So my median is 45, my Q1 is 43, my Q3 is 48. So using these 3 numbers, well, 43 is up there. If I have 200 of each, what percent is here? 25%, which was 25% of 200. 48, less than 48 is what percent? Which would be how many people out of 200? Between 43 and 48 would be what percent? And what's 50% of 200? These numbers are not drawn on that graph. What's our answer, first of all? But the biggest issue is down here. I drew a box plot to go with these 3. What would most of you draw to go with this one? So these are a box plot. What's the most common graph we draw where we use median or mean and standard deviation to draw it? The curve. Can I do that one? Why? What does this problem never tell me? When's the only time I can draw that? What shape is that? So I can't use any of that. So I can't, because this one here, if it were normal, this would be 50%, which would be 100 of them. But because it's not normal, I can't use that, which means it's not that. Uh, 26. Just looking at this really quick. Standardized score of negative 1.2, which means I am what in relation to the what? If I have a z-score of a negative number, that means I am what from the what? What does it mean to be negative? Below. What am I below? The mean. Well, my mean here is so you can immediately mark out two answers because they're not below the mean. But most of you are going to go straight to solving it. My equation for z is x minus mu divided by sigma. My z is negative 1.2. My x is what I'm solving for. My mean is 1045.7. My standard deviation, 221.9. And then you're just doing math at that point. One thing here, and I didn't see this the first time. What could somebody possibly get confused goes there? Okay, let me do something different. So if this is x bar minus mu, then this would be sigma over square root n. Why is it the green equation and not the blue equation? One word. Well, could be 3 words, but. And why does that tell me green and not blue? It's not a sample, it's just an individual. So this one's talking about an individual, this one's talking about the mean of a sample. And that's the reason you go with that one and not standard error of the mean. What's this one end up being, like 7, the 7 one? Where's this? I don't know why I didn't write the answer. 26 is B. 779. 19. It's a pretty easy one. But there are a couple things I want to talk about in the problem itself. A television news editor would like to know how local registered voters would respond to the question, are you in favor of the school bond measure that would be voted on in upcoming election? A television survey is conducted during a break in the evening news, which means what at this point? If I am conducting a survey during a break in the evening news, am I getting a good sample? So am I only targeting certain people?
Yes.
Which means what's that word?
Bias.
Yes, more specific. There's a sampling issue. There's a word for the fact that some groups could never have been possibly selected. Starts with U. Just this part. Under coverage. And just this part is saying under coverage. Now, during a break in the evening news also means people that are watching the commercials, which is also an undercover part there. But now continuing, that's not the only issue. By listing two telephone numbers side by side on the screen for viewers to call in if they approve. What's my issue there? Voluntary response. And another one, if they disapprove, the survey can produce bias results for a number of reasons. Which of the following is the most obvious? Stratified sample rather than simple random sample, yes or no? It's not doing either one of those. People who feel strongly about the issue are more likely to respond, yes or no? Which one is that one talking about? So it says which is the best or most obvious. Let's keep reading just in case. Viewers should be told about the issues before the survey is conducted. Well, maybe they should, but maybe that's not a reason for bias. Because if they're told, we might provide bias. Some registered voters who call might not vote in the election. Well, that's true, but is that a reason for bias? No. Wording of the question is biased. Are you in favor? No, I don't see any issues there, so it's definitely going to be B. Stemplot shows the yearly earnings per share of stock of two different companies over a 16-year period. I'm not going to go through every piece of this, but there is a major issue in this problem that people will have on the AP exam, and I want to discuss that. So let's say finding the range. What's the equation for range? Right, so for company A, what is my max?
$3.76 or $3.73.
So not only does it convert, but it's read upside down, and the one on the outside on this side is different than where it is here. What is my minimum for this side? But it flip-flops when it's over here. So over here, my max is what? Is it the one on the left anymore? $2.29, and my minimum is where? And that's the issue that occurs throughout all of these answers, but we're not learning anything more about a different type of problem. It's just making sure you're reading the chart right. If I end up between two numbers like here, I want to find median, and it ends up being between this number and this number. How do I find the median if it falls between $2 and $1.92? What? You average them, add them together, divide by 2. Your answer here ends up being D. Which, if you look at these, that one that's the only answer choice that you could kind of look at and figure out in your head. The mean here is probably going to be somewhere in the dollar something. The mean here is probably going to be closer to $2 something. All the other ones you would have to actually calculate, but that ends up being our answer. Number 3, a safety group claims that the mean speed of drivers on a highway exceeds. So if it exceeds, it's talking about null and alternative. Without writing any symbols or anything other than like the math symbol, like no numbers, no symbols, what has to go here for null? If we're talking about exceeds, what's going to go here for alternative? So null, null, less than, greater than, no, those should both be equal. alternative, we've got two, greater than or equal. Which one's correct? Because if you've already got equal here, you don't want it to be in both. So it's just greater than. And that's a pretty straightforward one. A researcher wishes to test a new drug developed to treat hypertension. A group of 40 hypertensive men and 60 hypertensive women is to be used. The experimenter randomly assigns 20 of the men and 30 of the women to placebo and assigns the rest to treatment. The major reason for separate assignment for men and women, this should be a very easy answer for you now that we've done today, is what? Why would we split them before we assign them? Not even looking at my answer choices. Word we've used today, it's talking about doing what in the experiment that we already talked about today? Blocking. So the answer here is blocking, but that's not an answer choice. Why do we block? Wait. I circled the wrong one. We block because we think that the thing we're blocking on might affect our response variable differently. So that is a possible source of confounding. Is it ever the case that there must be an equal number of subjects in both the placebo and treatment group? No. Do we want it to be? Probably, but it doesn't really matter. All right, so I only got two more. Independent random samples of 100 luxury cars and 250 non-luxury cars in a certain city are examined to see if they have bumper stickers. Of the 250 non-luxury cars, 125 have bumper stickers. And of the luxury cars, 30 have bumper stickers. We're doing a 90% confidence interval. We're doing Z because it's proportions. So looking through here, what is our Z for 90%? 1.645. So it's not this one. It's not this one. All of them say 0.05, 0.5 minus 0.3, so we don't have to worry about any of this. So we just have to worry about this part. In general, what it's going to ask about is, should we, what, or not? We have p hat 1, we have p hat 2, and sometimes we also have what? What's the? And when do we use p hat c? Only when it is a only when we're doing a what? Only when we're doing a test. When we're testing that they're the same, that equals 0. So should we be using p hat c here? No. So we should not be using the same thing on top and bottom. This one is 50%. This one is 30%. So which one actually correctly uses 30% and 50% in the standard deviation portion? A. Do look at your equation sheet really quick. It's on the back or on the like boxier side, the orange sheet. And the equation it uses looks a tiny little bit different than ours. It writes it as square root of p times 1 minus p times the proportion of 1 over n plus 1 over n. instead of writing P hat C 1 minus P hat C over N and P hat C 1 minus P hat C over N2, so that you would just distribute that. So this could be distributed to be both here and here, which is the same equation that we use, it's just written a little bit differently. And last problem that unfortunately still not everyone got right. In the scatter plot shown above, the least squared regression line, which one has the largest residual? Now, if I say which point is the farthest away from the rest, the answer would be what? C. Is residual concerned from the farthest from the rest? It's only concerned with the farthest from the what? So you're measuring this distance directly vertically. So our answer is A.